Welcome, Rupesh. So, we wanted to talk a little bit about the state of cloud security today, and that's why I brought you on. So, let's talk about what for you is one of the major issues that secure or more mature organizations are facing when it comes to cloud security and what can they do about it.
Yeah. First of all, Chris, thank you for inviting me, and it's a pleasure to be here. And I hope your audience likes what we have to kind of talk about today. I'm very excited to be here talking about things. So, just to answer your question around the bigger problems that mature security teams face, right? Like, and I have been over last 3 years been talking to hundreds of these teams, and these teams are actually kind of like, if you think about it, they have like a historical background. Either they have been migrating from their on-prem world to a larger cloud front, or they are just born on the cloud from day one, right? Like, and both the cases you'll see like huge deployments and a lot of migration. Their use cases are a little bit different in terms of like how they approach the cloud, but they face one consistent problem, and that is essentially securing themselves against adversaries who are very advanced. And the nature of the cloud itself is very open. It's a public cloud. If you think about AWS, Google Cloud, Azure, anyone can be a tenant on those cloud platforms, and you just need to go and create your accounts. And essentially what that means is these teams are not only facing and trust boundary issues on the cloud in terms of securing them from outside of the internet, but they also have to secure themselves from a shared infrastructure from other tenants on the same cloud. And on top of that, the type of uh, environment and infrastructure they use, it's also very diverse. Like, so they might be using a lot of cloud native services and infrastructure which is again shared between them and other tenants, and it starts to become a huge problem on like how to build this infrastructure securely, right? And I think if you look at the cloud breaches over almost the entirety of 10 to 15 years of cloud existence, it just keeps on growing. Although like these teams are putting in more and more effort, and it kind of relates to the complexity of the cloud and like more infrastructure they've built, right? Like, and it's a long answer, but the biggest problem that I hear and experience from these mature security teams is like, even with all the solutions that they have built around detecting the problems and remediating it, it's still a very complex environment, and they want to be build some preventions around how to build secure clouds while these problems exist in their environment.
So, as we think about that problem space and we kind of try to narrow it down, what are some of the root causes of some of these cloud incidents or cloud security incidents? What do you think causes that foundational problem?
Yeah, no, I mean, it's very good question, because if we don't understand like what's causing the problem, then there's actually really no benefit of talking like how to solve the problem, right? And there has been a lot of case studies done around the cloud breaches, and some of this comes from the actual cloud security vendors who are like responsible for basically identifying the problems, from open source cloud security practitioners around like just uh, tallying up all the known problems, putting it into GitHub repo, or maintaining an open source database of all these issues. And if you kind of like just look into all of those from either Cloud Security Alliance or some of those other uh, vendors, it boils down to core few of categories of problems, right? And almost 90% of those cloud breaches, if you realize, they are mostly around the shared tenant services on the cloud. Like, so there will be like some credential compromise, and that accounts for almost 53% of cloud breaches. Just how the cloud credentials can be created in the cloud, and how do you secure those cloud credentials, right? Like, they lead to almost 53% of breaches. Rest 47% of the breaches are due to the misconfigurations in the cloud. So someone left their S3 bucket open. This is like a traditional problem. People have now realized, and cloud providers have also put in a lot of controls to solve those things. But similar kind of multi-tenant services continue to be very complex in terms of their control, and these cloud providers keep on adding a lot of these features, right? So it's two reasons to be on a very high level, like credential compromise, 53% of cloud breaches, misconfigurations, that accounts for rest 47% of cloud breaches.
So it sounds like between credential compromise, which potentially some of the users um, have some responsibility there, but the rest sounds like configuration issues that are managed by the enterprise, by cloud users in general. So what can they do to reduce these misconfiguration issues?
Yeah. So I think the misconfiguration, or like actually not doing configuration, is definitely a big issue. And we have to understand, like, how do we understand where the actual enterprise responsibility starts in building those configuration versus what is the responsibility of the cloud provider itself, right? And essentially, it's called a shared responsibility model on the cloud, and both the tenant and the cloud providers share their respective responsibilities of like who owns what part of like security, and that's kind of not always very clear where the boundary starts and stop. And if you look at essentially understanding those configurations, and you'll be surprised, just on AWS, forget about other cloud providers, uh, there are more than 1500 IAM controls, more than 1500 IAM controls, right? Like, and that's kind of like, and this almost every year there's a 16% new cloud IAM controls that gets added. And when I talk about cloud IAM control, it's not just about the cloud identities or credentials. Cloud IAM controls also govern those multi-tenant services that cloud providers provide, like your S3 bucket, Dynamo DBs of the world. You have to configure them correctly, although they are deployed and they run in those cloud providers infrastructure. And the problem is all these multi-tenant services are directly accessible from the internet. So essentially, if you don't configure it correctly, uh, someone can just go and exploit those vulnerabilities or misconfigurations. And there's no easy way to understand how to build all these configurations correctly, because you have to also understand how this infrastructure is getting built, right? Like, and the developers and the DevOps teams are responsible for building the applications and the things that they're deploying, but they are not the most security conscious teams. And the teams who are responsible for securing the infrastructure, or the central cloud security teams, they don't have control over how the developers build their infrastructure. And essentially, this is also the next level of problem that happens because of different responsibility within the enterprise as well. And what is happening now is, we have seen like first generation of posture management control solutions, and now the latest, the second generation of posture control solutions, they do help these cloud security teams identify those misconfigurations. but end of the day these teams are not able to solve the problem. Those misconfigurations and vulnerabilities need to be triaged and resolved by the application teams. And so the security teams end of the day are just uh, mechanisms to identify the problem and assign the problem to the respective teams. And those respective teams again are not very security conscious, so they take some time to understand like what needs to be done for remediating those problems. And these infrastructures are huge, like, and if I just talk about one S3 service, I did give like a 1500 controls for IAM, but if you just look at one service S3, it has more than 50 controls. Now, it becomes very difficult for understanding the entire application access patterns around some data stored in one data store across different accounts. Sometimes it's shared with third party services or partners. And these application teams, it just becomes difficult to understand at very fine granularity of like what should be the access. And while the application behavior changes over time and the access pattern needs to be changed, keeping up with those changes just becomes difficult. And that's the reason why this vulnerabilities and misconfigurations are very difficult to solve, because it needs a lot of context around their use cases around access patterns. And it's not easily identified like what should be the actual access pattern. And there are different ways of accessing it. So you might close two doors, but then there are other three doors that you didn't even think about, and not your even your solutions that you are using to understand those access patterns. They also do not tell you about those controls, while these security solutions are also evolving.
So it sounds like a double-edged sword for the security teams. On one hand, they can't granularly control the applications, but then on the other hand, they also have to struggle to keep up with all the changes in identity and access management configurations from the cloud uh, service providers. What are some of the things that they can do about that?
Yeah, no, I mean, I think that's a very good question, and that's the actual exact problem we realized. Like, it's not easy to kind of like really be well fine grained around all the access pattern. So we took a little bit different approach to solving this problem, right? And this is not a very new approach in terms of like architectural reference from standpoint. If we look at how traditionally we have secured our environments, like our natural places where we stay, or like the way the security architectures work, it's always been like the first core objective of like eliminating the threat, right? And one of the way to eliminate the threat is by essentially use the time as a defender and create like those moats around things that we want to defend, so that like it builds a layer of shield, right? And that layer of shield has been different things for uh, different objectives. For an example, when we build our homes, we create a fence around it. Like, and think about like if we are a community builder, we have like created 100 homes, and we have to secure all those 100 homes, and they're different tenants with different requirements. It becomes very difficult to go validate like everyone has closed their windows, doors. So you kind of like build a fence around your community that kind of restricts some of those unintentional access patterns. Same thing for your data centers. What has happened is you want to isolate your infrastructure from the outside world, because we know like developers create their assets in the data center, and we don't want to expose all that vulnerabilities and misconfiguration to outside. So over 20-25 years of data center construction, we have identified a pattern of building the network perimeters around the data center using firewalls and other mechanisms. If you think about it, that level of perimeter and isolation does not exist for the cloud. That's an architectural gap altogether that is missing on the cloud. And we realized the data center world moved from the perimeter world to zero trust world over last 5 to 8 years. And it was essentially needed because what we had seen is the attackers were able to penetrate the perimeter boundaries in the data center, and then they could easily move inside laterally. And so it needed a newer approach of micro segmentation that eliminated that attack surface further. We started on the cloud with the thinking that the zero trust micro segmentation will work on the cloud also, right? And that's exactly the approach we took without even focusing on the outer boundary. And that's the whole reason we realized, like, from a centralized team perspective, the inner boundaries are very complicated to build because it needs the developer and application team understanding to build that zero trust boundaries, while the outer boundaries actually did serve a lot of good purpose of like eliminating the entire attack surface to begin with, right? And so we took like that approach rather than focusing on the internal east west isolation. Like, first isolate your entire cloud infrastructure by building the secure trust boundaries. And once we create those secure trust boundaries around the business requirements, then does it make sense around like creating those internal isolation. So that's kind of like where we are bringing in the innovation around, like, let's first secure the trust boundaries in the cloud and then go for like zero trust micro segmentation approach.
So you mentioned zero trust, and for folks that don't understand the premise behind zero trust, it assume breach, trust but like don't trust anyone but always verify, and then having the controls around least privilege. So it sounds like you're also taking that user data and network approach in creating different controls. Is that how you approach it?
Yes. So again, like a very good question. Now, the the trust boundary approach that we are taking on the cloud, although it sounds like a perimeter approach for the data center, it's a little bit different than that. Like how this thing gets done. Yes, end goal is to build that secure zone of trust in your data center that was essentially your north south firewalls. In the cloud, you cannot build that, right? Like, and if you think about the trust boundaries on the cloud, it's very different than on-prem. In your on-prem world, you had the network boundary first, and then the identity boundary inside of it, and then the data inside of the identity boundary. Whereas when you look at the cloud, your identity boundary is outside. So now it's switched inside out for your data, for your cloud. And then you can create your network boundary and data which are actually even side by side horizontally. Like, some of the data can reside inside of your network boundary in the cloud itself, and that's kind of like uh, essentially the cloud is a very different in terms of access pattern. And given like the risk boundaries that I just described, we have to take a different approach to building those trust boundaries. And the approach to solve the trust boundaries is essentially combining understanding the identities in the cloud, understanding the networks in the cloud, and understanding the data in the cloud. And then how do you combine these three things together in a very coarse grained way so that you can define the risk boundaries that a central security teams can operationalize, right? And whereas when we think about the least privilege policy that you mentioned, least privilege policy is about understanding a very fine grained access pattern. One example that will just make it very clear is, think about your least privilege policy as this user or application has access to this data. You're defining in a very fine grained control. There are many users, there are many data stores or services. You're very selectively identifying which identity has access to which data over which network. But when you think about a coarse grained enforcement, you are saying all my identities can only access all my data from any of my network. So it's a very coarse grained enforcement, but what it does is it makes sure that those three pillars of identity, data, and network always belongs to your trusted environment. So that way you can enforce this coarse grained control or a guardrail in your environment as a central security teams, and provide exceptions if someone is crossing those trust boundaries. And there are reasons why this is very beneficial, and we can kind of like talk, if you're interested to understand that pieces, like why doing this is very beneficial.
Yeah, we can jump into that for a second, but it my mind went back to the number you mentioned earlier of how many identity and access management controls there were, and how anyone can even keep up with now three planes, data, network, and identity, and even be able to manage that many identity and access management controls. How do they keep up with how to configure them, how they work? How does anyone keep up with that? Do the cloud providers provide help with that?
So cloud providers have done some actually good job around providing the documentation around those capabilities when they build it. They do provide essentially uh, notification ahead of the time when it's going in practice. But the problem is, even within the cloud providers teams, they're also very isolated teams, and sometimes they'll deploy controls which are kind of like they'll have some hidden apis for testing, and sometimes they'll not have like logging capabilities built in into those things. There is a very good talk on like how do you essentially go undetected in the cloud, that just happened at Black Hat last year. And that whole talk is around how to bypass detection in the cloud, right? And it's not because someone is not enabling all the logging capabilities, but even if you enable all the logging capabilities, cloud providers do not log everything. And the way the access patterns work, where those things are logged, are also very different. And one good example would be essentially think about, let's say if I misconfigure some asset, now the access to that asset by an identity that does not own, is not owned by your enterprise, will get logged into the account which is owned, which owns that identity. Now think about that identity is owned by an attacker, that logs will go to the attacker's log rather than your log, right? Like, and so you can bypass so this is just one example, right? Like, and there are like so many examples of like how you can just bypass all this logging capabilities. So although cloud providers provide all that notification and everything else around it, there are like still things to be done. And the pace at which they are essentially rolling up new services, new ways of access, although they want to be secure, they are in a rat race of becoming the better and best foundational public cloud, competing with other cloud providers, right? So security is still, if you look at actually I'll say third pillar in their environment. One, first is their functionality, second is availability of their infrastructure, and then only the security piece comes into play. So although like I would essentially say cloud providers do provide, but like there's a lot of gap that they also have to do. And it's very difficult like for individual security teams to keep up with those uh, insane amount of changes that this cloud providers are essentially innovating and providing new capabilities, right? And that's where I think the security vendors can play and do a better job of essentially making sure they understand what changes are done, and then kind of like building it in their platforms or the products. And that's how the individual security teams can scale, because then they don't have to keep up individually with all the changes around what's changing.
That makes sense. And going back to the last comment about fine grain versus coarse grain controls. Um, so the security teams can't control the fine grain controls,
Mhm.
and they have all these identity and access management controls.
Mhm.
How can they put the guardrails, as you mentioned, around their organization?
Yeah, good. So over last 2 to 3 years, I'll just take one cloud provider example and like talk through some of the examples so that it's more concrete. And for that thing, I'll just take AWS. So what they have done over last 2 to 3 years, they understood like essentially they were like uh, working with teams and companies who are migrating from on-prem world. These teams are asking for like, hey, how do I make sure I don't have any unintentional access patterns in my environment, which I could have guaranteed in my data center world. So to essentially support those customers, mostly around financials and like while they're moving to the cloud, they've built these capabilities which are what they call it as a perimeter controls. These perimeter controls are controls in their environment which are essentially separate controls than the assets that gets configured, right? And those assets or resources could be your identities or certain kind of services or data. Now if we just think about identities, there's something called service control policies on AWS. These service control policies apply at account and org level, and organization is a container for, you can put like multiple accounts together in one organization. You can call it as a production organizational unit, and have multiple production accounts inside it with infrastructure that belongs to individual accounts, right? Now the problem was like this infrastructure within all these accounts will talk to each other, and sometimes a misconfiguration will happen where the access will cross the enterprise account infrastructures, right? So what uh, controls that these teams have AWS has provided is around how to make sure the access for these identities originate from a network location that's owned by the enterprise, whether it's the infrastructure that's running on the cloud or an extended world like essentially their data center or like some SaaS service like GitHub when they access AWS. How do you make sure those access can be controlled? Let's say when these identities get compromised, they should not be used from locations that are not owned by the enterprise, right? So there are some guardrail controls around from where can these identities be used from, and then there are guardrails that can be used to control what can these identities access in terms of ownership. So can these identities access assets, services, data in an infrastructure owned by the enterprise or not, whether it spans the same account or organization boundaries. And you can control that using these centralized guardrails, control that these security teams can build, right? And that's kind of like how you will secure or build a boundary around the identities in the cloud. We have to do the similar things when we think about controlling or building these controls around like the networks that we create in our in the cloud. Same thing for when we create a resources in the cloud. You have to think about like how the resource access will happen. And it's very weird, people don't sometimes understand. In the cloud you can have a resource and provide an access to an application or any other principle without creating any identities. So for, and good example would be I can create an S3 bucket, and I can in that S3 bucket specify who can access this data. And you don't even have to have a IAM policy for an identity to access the data. And essentially what that means is access to the data is independent of any other controls in the environment, right? So same data can be accessed through now an identity configuration, and the same data can be accessed through a resource configuration. And that kind of like becomes so weird in terms of like understanding how to look at the exposure, because it's not just the configuration but also the team who owns those configuration. The cloud IAM configuration will be owned by the cloud, identity configuration will be owned by the cloud IAM teams, whereas the resource configuration will be owned by the DevOps or data security teams. And now these two teams don't talk to each other, and that's the reason why you will find like, oh, there are all these holes that appear because of responsibilities across different teams, different ways of providing access. And yeah, that's kind of like the whole gamut of like how to build those secure trust boundaries in the cloud.
Well, wow, we've already reached our time today, Rupesh. So if anyone has any additional questions, reach out to myself, reach out to Rupesh, and we can help you with getting more details on how you can do this for yourself and how you can get more information about InstaSecure. You can visit instasecure.io, check it out yourself. Thank you very much, all. Have a great day.
Thank you, Chris. It was a very nice talking to you.